Today's lesson 4.3 is on right triangle trigonometry. So this is kind of reviewing of what we did previously last week. So knowing that sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, tangent's your opposite over adjacent, and that cosecant is the reciprocal of your sine function, which is hypotenuse over opposite. Secant is the reciprocal of your cosine function, hypotenuse over adjacent, and cotangent is your reciprocal function of tangent. So it's adjacent over opposite. Remember that the side across from your right angle is always your hypotenuse. Then your side opposite or farthest away from your angle is your opposite side. And then the other side is your adjacent side. So kind of reviewing some of the things that we did last week. So if you are given a triangle with three sides and all sides are given, then you can find the six trig ratios. For instance, sine, well, let's label our sides first. So if this is our angle, we would label this at an opposite side. This is our hypotenuse, and this is your adjacent. So sine is opposite over hypotenuse. So we'd say 4/5. That means that the cosecant is the reciprocal of that. So the cosecant would be 5/4. If we do cosine, cosine's adjacent over hypotenuse, which is 3/5. And cosine, the reciprocal function is secant. So that would be our 5/3. Tangent is opposite over adjacent. So we have 4/3. And the reciprocal of that is our cotangent, which is 3/4. Now, if they gave you two sides and you were missing one, you would just do Pythagorean theorem to find the missing side. This is something we did last week. Also, we talked about the 45, 45, 90 triangle with the 1, 1, and the square root of 2. That is something, again, that you're going to use a lot as we go through. We also found all of our angles for 45. So we found the sine, cosine, tangent, and found all those ratios. Remember that we did not want to leave the square root in the denominator, so we adjusted that accordingly. We also talked about our 30, 60, 90 triangle because our big angles that we look at are your 30, 45, and 60. And we talked about how we took an equilateral triangle and divided it up and found the missing sides. So we have 1, 2, and the square root of 3. And those triangles will help you find the values of those trig functions. We did this as well. We did the sine, cosine, and tangent and the cofunctions, their inverse functions for 60 and 30 degrees. So we found all of these ratios in the previous lesson. And here's the 61. So what's new? Okay, so sine and cosine, they are, if you look at 90 minus theta and theta, they're what we call complementary angles. Complementary angles are two angles that add up to 90 degrees. So if you think of a regular triangle, if we have a right triangle, that means that this angle has to be 90. That means the other two have to add to 90. So those other two angles are complementary. So if you're looking at what that means in terms of sine and cosine, the sine of theta has to equal to the cosine of 90 minus theta. So this is an identity. So this is something that you will need to remember because they will ask you, okay, sine of theta, let's do sine of 30 degrees. Sine of 30 degrees is equivalent to the cosine of what? Well, it is equivalent to the cosine of 60, okay? And we can look at our triangle here, and this isn't drawn very well, and say this is 30, 60, and 90. We know this is square root of 3, 2, and 1. So if we find the sine of 30, sine is opposite over hypotenuse, which is 1/2. Cosine of 60 is adjacent over hypotenuse, which is also 1/2. So you can kind of see why that works or how it works. So again, a big thing to remember is that the sine of theta equals the cosine of 90 minus theta. So we have a whole bunch of identities here. These are called your cofunction identities. So that right there tells you the sine is equal to the cosine of 90 minus theta. Or the cosine of theta is equal to the sine of 90 minus theta. So those kind of go together. Your cofunctions, tangent and cotangent, go together as well, and secant and cosecant. Your reciprocal identities, we talked about these previous as well. So sine is 1 over the cosecant, cosine is 1 over the secant, tangent is 1 over cotangent. And you can do the same thing with the reciprocal identities. So cotangent is 1 over tangent, secant is 1 over cosine, and cosecant is 1 over sine. Quotient identities, this is something that we haven't talked about yet, but tangent is defined as sine over cosine. So if you know the value of sine and you know the value of cosine, you can divide them to find the value of tangent. Vice versa, since they are reciprocal identities, the cotangent is the cosine over the sine. The other ones that are important to know are these Pythagorean identities here at the bottom. The most popular one that you see is your sine squared plus cosine squared equals 1, but you have others. You have tangent of theta plus 1 equals secant squared of theta. You have cotangent squared of theta plus 1 is equal to cosecant squared of theta. When I do this in my regular classroom, I always have them create a note card. That might be something that you want to do as well. Put all your identities on the note card so that you have them to reference quickly and you're not flipping back and forth in your notes. So what if you're given something like this? Okay, we have the sine is 0.25. Well, we can write this 2 different ways. We can write this as the sine is 1/4, or you can think of it as 0.25 over 1. And that's what they're doing in this problem. So sine we know is opposite over hypotenuse. So they put the 0.25 in the 1. But where did they come up with this 0.9682? Well, they used the Pythagorean theorem to find the missing side. So we would have something like x squared plus 0.25 squared equals 1 squared. And when you work that out and solve that for x, you get 0.9682. And that's where that is coming from. So now we need to find the other trig function. So it's asking us to find cosine, tangent, and secant. Once we know all 3 sides, we can do that. So the cosine would be 0.9682 over 1, or just 0.9682. Tangent would be 0.25 over 0.9682, and I would go ahead and divide those out. The only time I wouldn't is if they were asking for an exact solution, which this would not be exact because we did round that 0.9682. So that gives me, and I'm going to go 4 decimal places. So 0.2582. And secant. Well, secant I know is the reciprocal function for cosine. So that would be 1 over 0.9682. Again, I'm going to go to my calculator. 1 divided by 0.9682. And I get 1.0328. And that would be what you would do for that one. Again, same idea here. This time they are saying the secant. Well, secant is the hypotenuse over the adjacent. So that means my hypotenuse is 4 and my adjacent side is 1. Again, if you set up the Pythagorean theorem, 1 squared plus y squared equals 4 squared. You get y to be the square root of 15. And this would be 1 with the square root of 15 that you will probably just leave it that way. And that would be exact. So if we were trying to find the sine, it'd be square root of 15 over 4. Then we would have the reciprocal, which is 4 over the square root of 15. Get rid of that square root of 15 on the bottom. You have 4 square root of 15 over 15. Cosine would be 1/4. Secant, we already know the secant, it was given, it was 4. Tangent, square root of 15 over 1, or just square root of 15. And then cotangent, 1 over the square root of 15, which is square root of 15 over 15. So we're using our right triangle, we're finding those given ratios. And I believe that's a repeat of the previous problems. If you have any questions or concerns on this section, please just send me an email and have a great day.